Alrighty, guys. So today we have colligative properties. Change, and we'll do a little sub thing, change calcs. Okay, so we're going to be looking at the boiling point elevation and the freezing point. There we go. Depression. Okay, so we know that from past videos, from past lessons, when you add a salt plus a solution, these things change. Okay, they are not the same anymore. Okay, we know from ice on our roads, okay, that when we put salt on it, the roads are now just wet. Okay, the ice melts, and that is because we added this salt to it. We have decreased the freezing point to where it is no longer frozen. It is still a very low temperature, say like -10 degrees Celsius, but it is not at its freezing point because there is a salt present. Okay, so we are going to do some calculations to figure out what the new freezing point or boiling point of a solution would be. Okay, now these calculations are very, very similar to each other. So they both look like a change in temperature. So that's a change in their boiling points, a boiling point change, or boiling point or freezing point. So change in their points. We'll do change in freezing point or boiling point is equal to I, which is our, we'll write it down here, I, it's our Van't Hoff factor of the salt. And then we have KF/B, which is KF/B, a freezing/boiling point constant. That is, you guys might be able to hear the sirens in the background. It is specific. We'll do specific to the solvent. Okay. So that freezing/boiling point constant is specific to what this salt is being dissolved in. Okay. And then lastly, M, the molality. Okay, so turn to green. There we go. M is the molality of salt in solvent. Okay, that's all you need. That's everything in these calculations. Okay, so if we do an example one, say I have, let's say I have 20 grams of NaCl in say 200 kilograms of water. And we'll make it 200 grams of salt, just to make it more realistic. Okay, 200 grams of salt and 200 kilograms of water. Okay. Now, I want to know new boiling and freezing okay. I'm going to have two calculations here. The first one, we'll do different colors. Delta T freezing point. Now, the Van't Hoff factor for sodium chloride is 2. Sodium chloride breaks up into 1 Na plus and 1 Cl minus. So that is 2 different ions, meaning it is a Van't Hoff factor of 2. Okay, my Van't Hoff factor is 2. I need to be able to calculate the molality, and so 200 grams of NaCl. I know that the molar mass of NaCl is 58.44 grams per 1 mole. So when I find out how many moles that is, I get 3.42 moles of NaCl. Okay. I divide that by the kilograms of solvent, which is 200, and I get a molarity, or sorry, not molarity, molality, a molality of 0.0171, and that is moles per kilogram. Okay. I'll erase all that so it doesn't get too cluttered. And then, lastly, I need to be able to have the freezing point constant for water, okay, because water is my solvent. So that is something that should be given to you, or you will have a table of them. And the freezing point constant of water is 1.86 degrees Celsius per molality. Okay. So we have molality here. When you multiply molality by a centimeter, not centimeter, Celsius, degrees Celsius, the molalities cancel out. When you multiply all this together, you get 0.0636, and that is degrees Celsius. Now that is the change to the freezing point, and we know it is a freezing point depression, and so the freezing point of water is 0 degrees Celsius, and if it's a freezing point depression, that means the freezing point is going to decrease, and so we have to do minus 0.0636, and that is, I can't believe I'm dumb enough that I went to my calculator, it's just negative 0.0636 degrees Celsius. There you go. Okay, there's the new freezing point for this solution. Okay, let's do the same thing for the boiling point. The boiling point, delta TB, is equal to 2. It's the same Van't Hoff factor. It's the same molality. However, there is a different constant. That constant is specific to the boiling point, and that is 0.51 degrees Celsius per molality. Okay, so when we do this calculation, multiply everything together, we get 0.0174. Okay, that is degrees Celsius. Now that is added, it is a boiling point elevation, so that is added to the boiling point of water, which is originally 100 degrees Celsius. So plus 0.0174, and so that is 100.0174. 4 degrees Celsius. Okay, with sig figs, doesn't really change a whole lot, but it is a new boiling point. Okay, this is not a very strong molality solution, so it shouldn't change very much, but that is how you do these calculations. We can find our new boiling points and boiling points and freezing points. I guess it would be the same thing as the melting point with these calculations. Okay, this is the important equation. So, good luck. If you have any questions, let me know, and I will see you in the next video.